Good morning or good afternoon. Welcome to this webinar on why your ERP is not helping you in production. My name is Mark Lilly with Protected Flow Manufacturing by Lilyworks. Why your ERP is not helping you in production. And we're going to talk about how to fix it without having to replace your ERP, because that is quite a chore, as anyone who's been through that. So let's talk about what's going on. A bit of a historical perspective to start out. What were manufacturers doing back in the 60s and 70s? Well, things have changed certainly, and you know, in addition to these groovy kind of funky colors, manufacturers were making stereos, TVs, refrigerators, you know, standard products with a standard bill of material and standard routings or operation steps. To manage those standard products and building those, MRP came about through the advent of computing. Right, so before computers, everybody was doing all this planning and scheduling manually, right? So MRP comes along and wow, pretty neat. I can take my sales orders and my forecast, put that together in a master production schedule or production plan, put together my bill of material of my standard product structure and what inventory I have on hand, put that in a computer, and voila, MRP runs, comes out with a material plan showing me which purchase orders I need to push in or out or create, as well as work orders, and work orders at any level of the BOM. So, you know, on a refrigerator or stereo, it's pretty deep BOMs. So I'll have a lot of work orders coming off those, and MRP is going to help me manage when I needed to have those work orders done by assigning a due date based upon a standard lead time, and you know, giving me kind of what I needed to produce in order to meet my production schedule and my production plan with the top level items and the dates that I wanted to have those top level items in inventory for. So the question soon came about, well, can I do that, right? MRP is generating a lot of work orders for me with a lot of areas due dates across all the levels of my bill of materials. So can I actually build all those work orders in the time frames that MRP is telling me I need to? Will I have capacity to be able to do that? Well, the first answer shortly after MRP came out was computing capacity got to a point where we could answer from a rough cut standpoint, and rough cut essentially means on an infinite basis, right? Assuming unlimited people, machines, when would I be able to get, or would I be able to get this all these work orders done? So it did give me somewhat of an answer, but again, not something I could really use to execute out in production because, well, it's infinite, and infinite is not reality, right? So so it did at least give me an answer as to where I was going to be overloaded in the future. So a good first step. But the computers at this point, we're talking 70s, really just weren't able to handle the idea of a constraint or having, you know, a constrained resource, okay, or simply finite capacity. The 1980s rolled along, and what's happened at this point is very much a bit of an industry is developing around MRP. Ollie White in particular has his training and consulting firm, and he and others who are doing this are realizing that not many companies are very successful implementing MRP, And the reason it's decided is that, well, it's not integrated enough. You need to have more of the company built into this picture to be able to really do a solid plan around manufacturing operations. So now, grab my pointer here. So now, instead of just doing a material requirements plan, kind of right these two blocks here, we're talking about going upstream and looking at strategic planning from a high-level business standpoint, budgeting of the company through input of the master schedule, all the way down to the execution out on the shop floor, where we're literally, monitoring and measuring performance and priority control down here in the execution of the plans out in the shop as well. So now that computing power is increasing, people are seeing the capability of computers, and really the thought process is the more we can get on a computer, the better off we're going to be, right? What's interesting is this little fine text down here, fine print down at the bottom, and apologize if you can't read it, but it essentially says, around 1980, over-frequent changes in sales forecasts entailing continual readjustments in production, as well as the unsuitability of the parameters fixed by the system, led MRP to evolve into MRP2, or manufacturing resource planning. So again, it's kind of saying, wow, there's so much change, and in order to adapt to that change and the frequency of change now in manufacturing. So I think what we might have seen there is kind of the move from standard products into a bit of custom products as well, make to order manufacturing. So now these changes just keep coming. They just keep coming, and now we need to take a bigger picture of what's going on here. So one of the big areas is scheduling, right? So computers are getting more powerful. Now we are able to do finite capacity scheduling. The priority in the scheduling programs and on any work orders in the MRP2 system is a due date, essentially, which we'll talk about in a little while. And essentially, the initial programs here are doing a capacity loading algorithm where it's loading the operations of all your work orders in either a forward direction or a backward direction. And we'll talk about that a little bit as well. I'm going to digress for a moment, just to point out that when we look to ERP, or we look to APS systems, even those bolt-ons to ERP that are doing scheduling for us, we often expect these tools to give us an optimal production schedule, right? Given our set of work orders, our set of operations on those work orders, just pump out, run that scheduling program and just give me my optimal schedule, the best way to execute out on the shop floor. Well, not to belabor this too much, you can go look this up for yourself, but if you look for job shop scheduling under Wikipedia, it actually talks about how the production scheduling problem is actually something called in computer science, and is called NP complete, which essentially means that there's no computer in the universe that's going to be able to solve this problem for you in any less than probably thousands of years. Okay, so we really need to stop expecting and looking for an optimal production schedule, because it doesn't exist. So fast forward a little bit up into the 90s. So now you've got these MRP2 systems. Folks are starting to recognize this. It's becoming quite an industry with these systems, quite successful, and now it's branching out into maybe not just manufacturing, right? So a lot of companies are looking at using these tools to help manage their system, their processes. So what's happening is that the breadth of the functionality that's being developed around MRP2 is just expanding. So in the 90s, Gartner actually renamed MRP2 into ERP. So not just manufacturing resource planning, but enterprise resource planning. And if you look at this graphic, it's telling, because really nowhere in the scope of enterprise resource planning, except maybe right there, do I see any mention of manufacturing. Okay, and in fact, it's also, and by the way, I pulled this graphic right out of actually the Wikipedia entry on ERP, so you can take a look at it there. But what's also kind of telling is that even in the production area, they're calling it PLM, which is really not correct. PLM is product lifecycle management, which is not, it's kind of like engineering. It's not related to helping you in production all that much. So what's happened? Manufacturing was literally and figuratively dropped with the transition from MRP2 to ERP. And really, there's been little to no innovation in the core manufacturing and production management functionality in ERP since the design of MRP in the 70s and finite scheduling in the 80s. It's a hard pill to swallow, but I think if you look at it, it's the reality. So why is your ERP not helping you in production? Well, because your material planning is essentially based on MRP, which was designed for make to stock, not really make to order. 95% plus of the manufacturing companies in North America today are make to order, or certainly some flavor of make to order. MRP is based on pushing production out onto the shop, right? Generating a forecast or production plan and pushing that out rather than pull-based, which based on actual demand, which is again is typically the mode most manufacturers are operating today. If you are in a situation where you're needing to manage inventory, whether raw materials, finished goods, or subassemblies, you have to understand that the design of MRP is ideally to get you to zero inventory, okay, where your supply nets out perfectly to match your demand so you get to zero inventory at some point in the future. Well, when you think about it that way, it's a little crazy because you don't want to have zero inventory if you're having to manage inventory. You want to have enough inventory at all hands, okay? It also is trying to guess the timing of when work orders need to be complete, again, at any level of the BOM based upon quote unquote standard lead times. So the deeper your BOM, the more, and we know our standards quote unquote are, you know, a good guess, right? So you're guessing across these multiple levels. So once you get down to a lower level in particular, who knows what kind of date you're going to get from or whether that's actually going to match your reality based on when you need to build that low level subassembly, okay? What many companies using MRP see and feel is this bullwhip effect, where planners, you've got planners on staff and they're struggling on a day-to-day basis trying to manage having too much or too little of any particular item, okay? There is a concept called demand-driven MRP. It was started in 2009, I believe, ultimately, by Carol Patak and Chad Smith. Carol was the president of APIX in the 2000s for several years. It's a vast improvement over managing inventory and its approach. Very few ERPs today have or know about demand-driven MRP concepts. I'm going to stop there with demand-driven MRP. If you want to learn more about it, its approach, its techniques around managing materials, then go to the demanddriveninstitute.com. That's a great educational website that talks about this concept and how it greatly improves upon the traditional MRP model. If you're in a situation where you have multi-level bills of material, okay, whether you're building those levels specifically for and in the same lot quantities of the parent that needs them, right, kind of a make to order subassembly model, or perhaps you have subassembly work orders that are being built separately on purpose because maybe that subassembly is required in multiple parents, or it's a common part. So, and maybe you're even stocking those subassemblies. Okay, you want to have them on hand for whenever any particular parent needs them. If you're in this type of situation, you're very likely spending a lot of time managing these separate work order due dates and those dependencies. If you have really deep BOMs, and I'm not even talking really too deep, but maybe 3 or 4 levels or more, you likely have someone in your company, maybe multiple people, dedicated to managing these due dates across work orders and these dependencies to make sure that you're going to have these subassemblies ready for when the parents need them in production. Okay. Again, you'd think this is something our ERP and MRP would be helping us with, but simply because of its design, it's not. We can talk about the finite scheduling or the scheduling tools that are in ERPs today, and what you find is a wide array. Some stop at infinite scheduling, don't even have the finite, but even where you do have finite scheduling, it's typically either a backward type of capacity loading algorithm or a forward capacity loading algorithm. In a backward direction, there's no room for variability, right? Which is a fancy way for saying, stuff happens in production, right? So if you think about what we're doing with the finite, with a backward finite schedule, we're saying, let's assume that the last operation of every work order, let's plan to have that finish on its due date, right? When you think about it that way, it's crazy. There's no room for stuff that's going to happen, whether it's contention between resources, tools breaking, people not showing up, material not being there, on and on. You probably live this every day, so you know what sort of stuff happens in production. Okay. From a forward scheduling standpoint, little better. There's room for variability, but arguably and possibly maybe too much room. What we see in forward scheduling is there's not really an objective point in time where we know where we need to start a job that's not too late but not too early. So if you don't have, just in general, if you don't have visibility of when the right time to start a job is, what are you gonna do? You're gonna start that early, right? And maybe really early to protect yourself. Okay. There's this concept called Little's Law from mathematical Q theory that essentially says the more stuff or things or people or items you put into a quote unquote system, and in Q theory, a system can be, a grocery store, an amusement park, a highway, your manufacturing shop floor, right? So you're coming down an on-ramp onto a 5-lane highway, and all you can see is the red brake lights on, you're going to be on that stretch of highway for a lot longer than if the cars were just whizzing by you at 70, 75 miles an hour, right? So same sort of thing in an amusement park. Let's say you have 5 rides you want to go on an amusement park, and maybe we should talk pre-COVID in this example. But let's say during a spring break we go to this amusement park. We're going to be there a lot longer than if we're able to go, say, the 3rd week in September, right, when there are fewer people there. Same thing happens in a manufacturing shop floor. The more jobs, the more work orders you send out into work in process, the longer period of time any one of those work orders is going to be in WIP. The neat part about it is that the inverse is also true. The fewer work orders you send out, the faster any one of those work orders is going to flow through all of its operations. Okay? So with forward scheduling, it doesn't have that starting point to prevent us from sending, and in fact may even encourage us to send too much out into WIP too soon. Okay, flooding WIP, confusing the true priorities, and generally slowing things down. Okay, this also can create a situation where we're buying material too soon. We've seen situations where folks are, because they don't see the right time to start a job or work order, they're buying material way too far in advance, sometimes months too soon. Okay. Operations, in finite scheduling, operations are placed based on this capacity loading algorithm. It's not really reflective of how execution actually happens in production. One of the comments we have often heard with finite scheduling is that it's jittery, meaning a simple due date change of one work order may entirely reshuffle the whole resulting order of the operations that the capacity loading program comes up with. And so it's really changes a lot. It's only as good as the last time you ran the program. What happens once that program ends? Well, invariably, stuff happens. Things change. Customers call, change the dates, right? Things happen in production. Now that resulting order, even if it does reflect reality somewhat, is not going to be believable anymore because things have changed. So there's often a disconnect between the resulting dispatch list that you send out from the results of having run the scheduling program and the priorities from the latest production meeting that you went to, where you understand what the true priorities are. All this being said, is it any wonder why you're struggling seeing right now, at this moment, just the simple answers to questions like, where is the job? How is it progressing? Do I have materials from whether it's from a PO or an inventory, or from another subassembly work order, from the previous operation step on the routing? I'm in one department. Is the material available in the previous one? Should I go look? Should I even bother go looking for it yet? And when I am in any work center, I've got 5 or 6 different work orders sitting there. Which one should I pick? Which one is most important to be worked on right now, either shop-wide or particular to any work center, or even down to the machine or person level? Never mind seeing into the future, right? Is it any wonder we're struggling with visibility in the future? Telling my customer when they're going to get their order, where my bottlenecks will be. What can I do now to change my future for the better, to improve my on-time delivery and to improve my bottom line? So how do we fix this without replacing your ERP? We're going to use what you do have now. We're going to use that work order and job information you've got in your ERP. We're going to use the operation steps and routings. It's okay if the estimated setup and run times are not 100% accurate. I understand. You've been told by all the consultants, if you're going to use your ERP scheduling tool, they better be 90–95% accurate. And that's true, because the scheduling tool uses those times to build your schedule. Okay, it's not as important in what we're going to show you here. In fact, even if you don't have work orders or routings in an electronic form, on a spreadsheet or in your ERP, that's okay too. We have a place where you can create them and keep them. This tool is going to pull in your jobs and work orders from your ERP. So for this, I'm going to assume you do have jobs and work order information in your ERP. This can be from a spreadsheet, as often as you want to do it, or it can be a direct integration, okay, to automatically pull your information over This can be a full reload of all your work orders, all your jobs, and all their associated routings, or you can do a net change. Okay, just show me new jobs, just show me changes and updates to existing jobs. Okay, however often you want to do it, whether you want that refreshed once or twice a day or every 10 minutes. Okay, this uses an ETL tool. ETL stands for extract, transform, and load. So I think the extract and the load are pretty self-explanatory, but the transform is the key idea here. And frankly, the opportunity of having a tool separate from your ERP. Because now we can take the information you do have in your ERP. As an example, I've got 4 work orders here, and it just so happens that this is the parent up here on the top, and I've got 3 sub-assemblies that have to be made before this parent can start in the welding operation up here. So if these are being managed independently and separately in your ERP, which they likely are, I mean, you might have something called a sub-job where they're tied together somewhat in that fashion. That's great. We'll use that information if you do. If you don't, that's okay too. But we want to take this information and now structure it so it's reflective of how you truly manufacture out in the shop. So now I want to specify, I want to show visually, here's my parent, and then here are the 3 sub-assemblies that need to be manufactured before that operation, that first operation in the parent can get started. Okay. Maybe you go deeper. Maybe it's a lot of work orders that need to be tied together. We can do that too with this transformation tool and the information you have today to reflect how production happens truly in your shop. What we do as that information comes in, as that work order information comes in, we create what's called a custom execution plan. So these are the 4 operations. So this is a simple single level job. We've got 4 operations on it. The width of each is determined by whatever setup and run times you do have. Again, give us 50, 60% accuracy. That's fine. We'll take it. And you'll see why in a moment. Okay. Now, you know, and I know if these were, you know, these are my 4 steps I needed to get done and it was due on Wednesday afternoon, it would be crazy, like in a backward schedule type situation, it would be crazy to actually release this on Monday afternoon and expect these to get done in perfect sequence, right? I need some, I know there's going to be contention between departments, between resources. There may be stuff going on during the operations. So I need some time protection here. I need a time buffer to make sure that I'm going to be comfortable getting this work complete by the due date. Right? As a result of creating this execution plan, what I also get is an objective starting point for every work order as it comes through. Okay? If we'll work through this buffer sizing and agree how big these should be, and they can be set at a global level, at a site level, at a part family level, at a part level, right down to the job level. Okay, we're going to talk about how we do that in setting these. If you feel comfortable, and we're not going to continue until you feel comfortable that there's enough time here sufficient to get this work done. So if that's the case, then why send it out any sooner and clog up WIP, slow things down, and confuse the true priorities? Now I have an objective starting point as to when I should start the job. That also is going to give me an objective material need date for any materials that are required for this job. Really don't need them any sooner. This execution plan protects my due date, and it protects me, it controls how much I'm going to send out into WIP across all jobs. So what we find is when this is implemented within the first few weeks or months, when this is implemented, your WIP goes down fairly dramatically because you're controlling across all jobs when you're sending that work out. Okay, So we often see at least a 30%, sometimes up to 40 or 50% reduction in WIP. If you're a CFO, or do the math on your WIP inventory values, right? And see what sort of cash flow benefits you would get by that type of reduction in a very quick time frame. The other thing this execution plan does for us is it establishes the right priority. We talked about how traditional scheduling methods use due date priority. It seems to make sense, and it probably did when we were making standard products. But now most manufacturers are not only make to order, but they're high mix. They're custom manufacturing environments, which means you will have jobs that are due 2 months from now that are more in danger of being late if you don't get started on it today, right, than a job that's due just a week or two from now. So if you're using due date as priority, you're actually paying attention to those jobs due sooner at the expense of the ones due later, even though they need your attention now. It's making those due later more and more at risk of becoming a late job. Here's our due date. Here's that release date. We have the actual work completed. Okay, again, I'm gonna look to the ERP for this. So you're gonna still report work order completion and operation completion over there. Again, if you don't have one, we can help you. Okay, so now I know what my remaining work looks like. There's the work that remains. The other half of operation 20, 30, and 40. From here to here is my time protection left. The priority is very simply the percentage of, this is a relative priority, so it doesn't matter if it is a 3-month job or a 3-week job or a 3-day job. The priority is the percentage of the work remaining divided by the percentage of your time protection remaining. Okay? We automatically, dynamically, and in real time provide that priority out in the shop. Okay? The idea is, if I'm doing work faster than this time protection is getting eaten simply by the passage of time, there's no scheduling programs here. It's simply looking at, by the clock goes by, this time buffer, your time protection is getting eaten up. And then as I'm reporting operations complete or partially complete, my work remaining is being adjusted. It simply takes that information in real time and shows me how much in danger of being late is this job relative to all my other jobs. If I have a multi-level job like this one, then I get a multi-level execution plan. And each of its subassemblies, simply as time comes in and hits the start date, is going to adjust that threat level simply as time goes by, as work is being reported to it. So I always can see what the priorities are on any level of build, any level of work order. And then I publish those threat levels out in the shop. So we can see by work center, by department, by person, by machine, whatever level of granularity you want to go, the work orders coming through that area or for that person and their priority. Notice what's not being shown is due date. I don't need due date here. I want to know which job, regardless of due date, needs my attention right now. And that's going to be the one with the highest threat level. Got a customer, and if you're in this situation where you have separate work orders but common subassemblies, right? They build many of these, like the side, maybe they'll build many sides because it's not just this disposal unit, but many others or other products that are also going to use this component, or certainly maybe even the motor or pickup hook may be used across other parents as well. And this is the way the work orders look in their ERP system, right? They're all separate. Somebody's having to manage all the due dates, all the dependencies, trying to figure out what they're needed and when they're needed and in what quantities. So we're going to take this information from your ERP just as it exists today with whatever due dates are on them, and we're going to turn this picture into that. Even though they're not structured with those arrows like the previous diagrams I showed you, even though they're separate work orders, we're going to turn this into this view so you know what quantities, and the timing of when to start and when these need to be finished to supply whatever their upper levels are. We can look at more information about where are we right now. In other words, where are all my jobs and how are they tracking? So I can see by looking at the execution plan where I am on one job. This is showing me across all jobs that I have released in production right now. Okay, ideally, I want all my jobs walking up this green zone where roughly work is getting done as time goes by, right? Or as time is going by. These in the blue zone, I've probably released too early. I'm reporting work done. This is the amount of work that's being reported. This is the amount of buffer that's gone by, right? So I've reported work done here, probably without even the buffer having started yet. So that may be okay, but if I'm sharing resources with some of the jobs over here, then it may be a reason why I've got so many late ones. That's kind of the here and now, though. How do I answer those right now questions? Now let's take a look at future looking questions, right? How can I, given your information, taking your information from your ERP, creating these execution plans, and by the way, you also telling us simply by having your work orders, I know what your resources are, I know what your work centers are. We're gonna ask for your calendar, obviously, too. How many production hours do you work, either specific to your site or to any department? And we're going to use that information too. We're going to look at your resource and see how are there any groups involved? Do you have a milling center with 5 milling machines? Do you have an assembly group with 7 assembly people? These types of things. So we can get an idea and a feel for your capacity and the capabilities within those capacity groups. And then what we're going to do is we're going to run a predictive analytics program, okay, based on that information. So we're going to take in this case, here's your work order, right, the one we were looking at before, and the remaining operations are that other half of 20, 30, and 40. So the question is, well, theoretically, I could get this work done in a couple days, right? But based upon all the other jobs that are going on out in the shop and my capacity constraints, then where actually am I going to be able to get these done? And after I run this predictive analytics tool, this allows me to see on a job by job basis where, when, and how each of the remaining operations is predicted to start and finish, showing me this job actually isn't predicted to finish until 2 days late. So again, I can run this program at any time. It's not a scheduling program. I don't have to run it at night or over the weekend. I can run it at any time during the day. And all it does is it simulates me using the execution method that I'm actually using out on the shop floor, the threat level status, or any overrides to that priority status that you decide to use. And it will simulate exactly how you will be executing out in the shop. So it truly is reflective of how execution happens in your production environment. So it's going to show you what the picture looks like, where your bottlenecks are going to be out in the future, the severity of those bottlenecks. And then on a job by job basis, I could click on any one of these operations within a given department. It's going to show me all the operations within that work order, bring up the execution plan along with it, and show me exactly why, when, and how each of these operations is predicted to start and finish where it is, based upon all the other work that will be going on in the shop in the future. After this runs, or actually as this predictive analytics tool, the simulation tool runs, it also stores a lot of useful predictive information, right? One of which is predicted wait time. So I can look out in the future and see where will my operations be waiting the most, and for how long, okay, down to the operation level, or I can see into the job by job level. So for each job, what the due date was that came over, what the due date is that came over from my ERP. It's going to then show me what the predicted finish date of each of these work orders is based upon the predicted finish date of its last operation, right? Do the date math for me. Show me how many days late each of these jobs is predicted to finish. I can then also see the severity of the wait time, the cumulative wait time that was calculated by resource out in the future. So this particular company worked a 4-day, 10-hour a week, 10-hour a day week, and we found that their the resource or department called Box Pack will have the most contention, will have the most wait time, predicted wait time in the future. So that will be their bottleneck. So what you can do there is say, well, I want to do a what if. Well, I can see graphically what my standard game plan looks like, right? So there's my predicted lateness out in the future. In this case, it's showing by month as well. And then I also put together a what if, we call them alternate game plans, where this is showing, well, what if I come in Fridays, but just in that that constrained resource, not the whole shop, just that department. And that's going to take my overall lateness across all my work orders down quite a bit, almost 100 days. So I can see that graphically or by the actual numbers. And there's my 100 days of reduced predicted lateness if I come in on Fridays in that department. The tool's called Protected Flow Manufacturing. It digitally transforms your information that you have today into the visibility and control that you need to manage production, working with your ERP. It's cloud-based, so you don't have to install any software. You don't need a new server. It's up in Amazon. It's very secure. We have ITAR customers running. And you essentially have access to it 24/7 on whatever device you want to run an internet browser on, whether it's a laptop, a desktop, a tablet, your phone, TV monitors out in the shop for priorities, or even reporting. We go back again to the 60s and 70s. George Plossi was one of the founders, the fathers of MRP, if you will, along with Ollie White and Joe Orlicke, and he came up with this first law of manufacturing. And it's a little bit ironic, but those folks certainly did the best they could, and they did great things with the tools they had available to them at the time, the computing power that they had available to them at the time. But George's first law states, okay, and again, this is a guy speaking in the 60s and 70s, that all benefits implied in a manufacturing company will be directly related to the speed of flow of information and materials. This tool is providing visibility where the work happens out in the shop to enable your folks to make the right decisions to speed the flow of material. And when he says all benefits, that's no joke. Imagine having greater visibility of the operational information to make the right decisions to improve flow. Your on-time delivery is going up, your WIP's going down, enabling faster flow, enabling on-time delivery, enabling shorter lead times through manufacturing. And this can happen very quickly. Most implementations are anywhere from 2 to 3 months to get live on the execution. And then the planning component is shortly thereafter. I do have a couple spreadsheets that could help you work through an ROI from both a personnel time and cost savings. How much time are we spending trying to do scheduling on spreadsheets or manually on whiteboards today and trying to get that information, as well as how much additional revenue and or contribution margin you would be able to generate. Contribution margin is a powerful lever. Actually, it speaks, where you increase any contribution margin, that's going to go directly to your bottom line. So this is a worksheet that kind of helps you understand, if I were able to produce or ship X number of more jobs per time period, say per month, how much more profit would that put on my company's bottom line, to the health of my company. I'm going to provide some handouts now. We're at the end. There's a brochure I'm going to provide called Time is Money. On the front is just a display of that graphical view of the multi-level structure. But take a look at page 2 as well. There's 4 very visual pictures or graphics, if you will, with each of the execution questions on top of it, right? Describing what, where is my job? How is it progressing? What should I work on next? When am I going to be able to tell my customer when they can get their order? Okay. I'll also post up some data import templates, or probably a template in a spreadsheet, as well as a PDF that has directions as to how to, what the data points are. It's really not very much. These are data points that we use all the time to do a proof of concept with any manufacturing company. So it's essentially work order header information. So, your job number, your part or description, your due date, your quantity being produced, whether it's released or not, and then your operations details, certainly operation steps, sequence numbers, maybe an optional description of what the operation is, certainly a work center, whether it's an outside service or not, and then whatever estimated setup and run times you have. Again, they don't need to be super accurate for us to help you here. And with that, just that information, however many work orders you want to give us, whether it's a full load or just a sample size of 10 or 20, we can take that, do a proof of concept, and show you how this would work today with your ERP, with the data you have. And we do these proof of concepts at no charge. With that, I'll stop, and as I post the brochures and the brochure and the templates, I will open it up for any questions. Certainly, I think there's a question section, so feel free to type something in there, or use the chat. I'll watch both and see what questions we may have. So let's see, go to handouts. And I'm going to choose a couple files here. Okay, that's uploading. And I think I have to wait for that to finish before I pick the next one. It's uploading at 50, almost 60% now. Okay, the PFM Time is Money brochure is up, and again, I'd point you to the back, page 2 in particular, to show the visuals of how we answer the execution and planning questions. Now I'm going to go and go to my templates and send you all a import template if you're interested at all in getting us some data to do a proof of concept or what that would look like. It's really pretty easy. So here's, size that out a little bit. Okay, that was pretty quick. That was just an Excel spreadsheet. That went up very quickly. That's available to you now. And I'm also going to give you a PDF that kind of describes the fields in the template and what we need there. And that went up very quickly too. So all 3 documents are up in handouts, so feel free to grab those if you like. I think I do see some questions. No, actually I don't. I see a comment from Greg Dow. Great session. Thank you very much, Greg. Appreciate you attending. Again, if anyone else, if you have any questions, feel free to drop me an email, hit our website, come through that way. We'll get the message. Doesn't look like any more questions coming in, so thanks everyone. I'll actually wait a moment just so if anybody wants to grab those handouts, they can. I'm not sure how quickly they're coming down for you. So thanks again, everyone, for attending. Any other questions or comments? And again, feel free to reach out, and hope you have a great rest of the week, great weekend. Bye now.